Students, welcome to lecture number 10 of the material informatics course, and we have been discussing about ensemble learning. We are going to continue this discussion and discuss two important aspects today, that is, one is this ADA boost algorithm, other one is gradient boost algorithm. I will introduce the subject of XGBoost algorithm also. Remember, these are very important algorithms in terms of ensemble algorithms. Maybe you were learning little early these algorithms in this course, because ensemble means many algorithms together, right. That word of the meaning of the word ensemble means basically what? It means many algorithms putting together, we can develop some kind of a learning. So, but slowly we will build up the case and hopefully you will understand the concepts very clearly. So, that is the idea. So, let us go ahead that, but before that let me first tell you what is ensemble learning. It is basically a very important method in which we combine many small models instead of using one model. So, what is mean is basically combine series of low performing models. What is the aim? Aim is to create an improved prediction, right. That is what. Individual models may not predict so nicely. So, we can put them together either in a series of parallel combination and create a high performance prediction. So, here there is very important aspect we must remember, individual classifiers vote and final outcome or final predictions then basically decided by majority voting. Please and remember this, it is not average of the all the models, it is basically these final decisions are made by voting and the performance is decided by the majority voting. So, it offers obviously much higher accuracy than the individual or base models. It can be either parallelized or it can be either in series combination like a series resistance or parallel resistance kind of concept, relation engineering. Many of us have already read that. Same thing can be done also, it can be models can be parallelized or models can be put in series. Ensemble learning methods sometimes are called meta algorithms. Why? Because they combine several machine learning algorithms into a single predictive model. That is why they are called a meta algorithm. These are different versions of that. This has one typical characteristic which makes them very widely different from others, is that it can decrease the variance using bagging approach. Okay. So, that is basically what we are going to talk in the next 10-15 minutes or so. It is obviously a very important one in terms of combining diverse set of learners, or we call it individual learning machines. Okay. In a simple form, we combine all the predictions collectively and decide the final prediction by majority voting. These models can be incorporated in both two parallel situations, when there are too large data or very large volume of data, when a data is too little. Both cases you can use these models. So, you can see here there one particular situation is shown here. We have a training data which are used as a bootstrap sampling. I discussed about bootstrap in the last lecture, and these are the base learner 1, 2, 3, and then each learner is going to give some predictions. Here you can see that majority prediction is obviously yes, because there are only one no and two yes predictions. That is so a majority prediction yes, that is what is the ensemble predictions. This is taken from Greeks.org. You can also look at this website, very nicely built in. So, therefore, this is one example in which you can see that learners are basically put in series combinations. This is what is another example. I have data and I can use 4 different learners. Lasso is a regression model, K-nearest-neighbor model which is a classifier, support vector regression model, or random forest. And then when all of these model predictions are taken together, we can always decide based on the voting which is the best prediction possible. Okay. So, this is the biggest advantage of ensemble learning. Since you are putting many models together, your chance of accuracy, or accuracy means predicting accurate accurate aspects is very high here compared to individual models. Individual models may predict differently, but when you put it together and decide on the majority voting, then predictions are much higher. So, it is used for various purposes. It can combine decisions, can be more accurate than individual algorithm, that is obvious. It can generate a group of best learners, okay, just like we always ask our students in class to give a group activity kind of project, right. Instead of giving individual student one project, we can give them a project together. So, they can learn together and they can come back with a much better project, right. That same thing happens here also. So, different learners use different kinds of algorithms, they can use different hyperparameters, features or training sets. Please go back my discussion on hyperparameters, I talked about it. So, algorithm means basically models, what kind of specific equations or models are used. Features means basically what kind of variables or independent variables are present in the model. Training sets basically means data. So, there are two main reasons why you use ensemble modeling. What? Single models, obviously performance. Second important aspect is robustness. Ensemble model reduces the spread of dispersion of the predictions. Remember this. This is very important. Any kind of predictions may have a large dispersion, plus minus error, right. That gets reduced by ensemble model. It obviously make better predictions, achieve better performance than any single contributing models. To give an exact idea, I am talking about pegging versus boosting here. There are two types of model, there are three types of model actually, pegging, boosting and probably what is that, stacking, right. Three models are there. So, pegging means what? Is models are trained, this is what is pegging on the right hand side, models are trained independently on different random subsets of the training data. These are then combined usually by averaging or voting, mostly voting. And here you see here original data was divided into different data sets. Here we have divided into M data sets, and there are learners G1 to GM. Each of the learners learn the data or get trained in the data and then predict. So, we always sum it over like this, GM is 1 by M, sum it over by 1 J1 to M GI. That is what is that. This is a parallel connections, right. You can see these are parallelly connected like in a electrical circuit, you can have parallel connections, same thing happen. On the right side, on the left side you have boosting, right. Boostings are basically trained one after another in models actually. Each new model focuses on fixing the errors made by the previous models. So, here you see they are learned one after another, they are not like this, they are learning one after another. G1 learns, then give it to the G2, G2 takes care of the whatever errors has been made by G1, correct. And you can always put weights alpha 1, alpha 2, alpha 3, right. So, these are the weights of on each of the predictions of the models, right. So, depending on the values of the weights alphas, the total predictions will be changing. So, you sum it over J1 to M alpha I GI, GI is the learner, okay, whatever each learner predicts. This is what the boosting means, okay. Pegging means parallel connections. So, therefore, I can write down this is series connection and this is parallel connection. That is the key difference between these two. By the way, in order to explain or complete the task, sequencing or stacking actually is basically called stack generalization. What is it? It multiple different models are trained and their predictions are used as input to a final model. So, you see the difference? Multiple different models are trained and their predictions are then used as an input to a final model. So, your final model is different from your initial models. Initial models are trained from the training data and they predict, and these predictions are then used as input to the final model, okay. And that is why it is called, always called as a meta model, because they are combinations of different kinds of models, and the meta models learns how best to combine the predictors of the different base models, okay. So, that is the basic idea. So, you have bagging, boosting and also you have stacking, right. Let me write down stacking. We may not discuss about stacking much, because that stacking requires separate discussions. So, in case of begging, what is done? Again, this is taken from Greeks.org. You have different subsets of data, right. You can see here different subsets of data, correct, training data, and there are different base models, correct, and each of these base models will predict, and then we basically take most frequent and average predictions. Normally, we rarely take average predictions, although it is written, we always take most frequent or the decide by the voting actually, which is the most frequent predictions. I hope it is clear now, because I have been giving different pictures, I have been showing different pictures, explaining the same thing in different ways. So, you understand what is begging very clearly. So, now in begging we use something known as a bootstrap sampling. Okay. Bootstrap sampling. Please remember, this is a keyword, bootstrap sampling. Let me explain what is that. Basically, what does it divides the original training data into n subsets. So, you have training data, let us say this is what is training data. You divide into n subsets. And then randomly selects any substrate. Let us say randomly I select substrate number 3 with replacement in some row from the other subsets. Do you understand that? So, first I divide training data into n subsets, then randomly select any substrates and replace in some rows the other substrates. Got it? Some rows. Say every data will have rows and columns. Replace some rows in other substrates. Okay. Basically, what does it do? I take those rows from the other substrate and put it in the substrate number 3. That is what we do, right. This step ensures best models are trained on diverse substrates, right. So, you understand, you may say, sir, why you want replacing these rows? Okay. So, we replace those because we want to have a diverse substrates, as diverse as possible. There is no bias in terms of the data in the training sets. So, first I am dividing the data into n subsets, that itself is going to create a lot of diversity. Then again I am putting additional thing, I am replacing some of the rows of subset 3, randomly pick the subset 3 and replacing some of the rows of the subset 3 from the other substrates. This is how actually you can make a lot of robustness in the model, the training process itself. Okay. This step ensures best models are trained on diverse substrates and there is no class imbalance. Remember this, no class imbalance, because data imbalance is a big problem in data informatics. This is a big challenge, right. Many of my research which we have conducted on various ceramics, we saw there is a huge data imbalance and we have to use different kinds of methods to take care of that. This is a very good method. Here you can take care of data imbalance very nicely. Please understand that. And best, so this is exactly what is this called bootstrapping. It is a powerful statistical method to quantify or estimating a quantity from a data sample. This is easiest to understand if the quantity is descriptive statistics such as mean or standard deviation. Okay, that is what we are doing actually. So, now in case of begging, we can use best models training. For each bootstrap samples we can train a best model, right. So, each bootstrap sample pair we can train a best model for each one. There is n bootstrap sample pairs. So, you can have n models to train, that is what we do, and these models may be weak models, may not be strong models, like regression, it is not so strong model, right, compared to descent tree or compared to SBM or compared to other SBR or even neural network. Regression is a much weaker model. So, we can train on these weak models. These weak models are trained in parallel. Obviously, in begging we always train in parallel, remember that. In begging we are making parallel training process, right, parallel training process, and to increase basically computational efficiency and reduce the time consumptions. So, we can use different types of best learners, weak best learners by the way, and make it possible to work. Bootstrapping is a very important step one must understand. I explained you nicely. Let me tell you again, I take the training data, divide the training data into n substrates, then randomly I choose one of the substrates and replace some of the rows in this substrate from the other substrates. Okay. Let us say I replace some of the rows in substrate number 3 from substrate number 2, right. That is what we do. And then what we do? We can apply base learners on each of these substrates. I have n subsets, okay. These are subsets. I have n subsets, I can apply n base learners. Then I can obviously parallelize it, as I have seen in case of begging and do that. This can be used in boosting also, correct. So, understand what is this, right. So, what is boosting? Well, boosting is very different from begging in the terms that here what we are doing? We are dividing data into different substrates, again same story. Then for each substrate we have different base models, and base model is predicting that. Okay, as you see here, I have already discussed, I am talking again and again because so that you understand. So, we have divided into different data sets, subsets, and we are putting different learners G1, G2, G3 to GM and do that. And finally, prediction is not directly summed over all the learner predictions, it is not. Instead, we are doing one more thing, we are putting a parameter called alpha. What does it do? This parameter alpha is basically weight factor, just like putting weights on each of these learners. So, some of the learners may be predicting differently from the others. So, I can put these weight factors on these learners, heavy weight factors, and make the decision much better actually. That is what is the idea is. So, in that case we can even differentiate between weak and weaker learners also. For the weaker learners we can put less value of alpha, for weak learners we can put place higher values of alpha, that is the idea. So, you understand, right, it is a series combinations, boosting is a series combination of learners or base models. Okay. So, it is basically ensemble technique which combines multiple weak learners to create a sorting or strong learner basically, and these models are trained in a series as we told you, and such that each next model tries to you can see that tries to improve on the mistakes done by the previous model. And this is we can always initialize model weights, begin with a single weak learner, assign some weights onto that, and the learner 2 will learn way such a way that all the mistakes done by learner G1 will be taken care of, and in addition we can put also a weight on learner 2, same thing repeats as you go on in the series way, right. That is the idea. So, it is a sequential learning process. Boosting works by training models in a sequentially, where each model focusing on correcting the errors of the predecessors, and boosting typically uses single type of weak models. Yes, this is also very important. In bagging we can use different types of models, but here we can use single type of, right. So, these learners can be either similar type or dissimilar type, homogeneous or heterogeneous, we already discussed in the last lecture, right. And these weights can be adjusted, alpha 1, alpha 2, alpha 3, alpha 4 to alpha can be adjusted. This is also adjustable parameter. Basically, all these are done to have a better predictive capability, remember this. Okay. So, this, as you understand, this is a very important model, this is what I discussed. Okay. So, now let me just move ahead. Stacking is, we are not going to discuss, but let me just tell you. So, I have data I divide into n subsets, and then put on each substrate I learn a different model, correct, and then I put all of them together and make a predictions. We stack them actually, we are stacking them all the models together. That is why it is called a meta learner, it stacks everything, that is why it is called a meta learner. So, now let us talk about little bit on ADA boosting, what is that. Okay. So, I told you there are 3 different models of boosting, ADA boosting which is called adaptive boosting, XG boosting which is called extreme gradient boosting, and gradient boosting learning. Okay. So, we will discuss ADA boosting and gradient boosting model. XG boosting we may not get time today, we may discuss in next class, or we can discuss further, because XG boosting requires you to discuss about tree structure like decision tree or this kind of structures. So, boosting, as you understand, is basically sequentially combine multiple weak learners to create a strong learner classifier. Okay. It is always done by training a model using a training data. Basically, we are dividing the data into different subsets and then train each subset of data by a weak learner and then evaluate it. Okay. Remember this. Please follow this red color text. In some cases, I have even put underline also, so that you can understand importance of that. The model is further built on that, so that which tries to correct the errors in the previous model. Okay. So, procedure is continued until either the complete training data set is predicted correctly or predefined number of iterations are completed. Remember, in a class, a teacher focusing primarily on the weak learners to improve his academic performance, right. That is exactly same as a boosting. So, when you go to the class, we always focus on primarily on the weak learners, weak students, those students who are not able to understand properly or not able to perform to the expected level, we always focus on them, and idea is to improve the academic performance. So, this is exactly done in boosting. In boosting, we basically use lot of weak learners, divide the training data into subsets and make the each of the weak learner learn from the training data and pass on the learning from one to other. So, whatever therefore, what are mistake done by the previous learner will not be committed by the next learner, and that is how we improve his performance category. Okay, performance aspects. Okay, this is what is done. So, it basically combines multiple weak learners. Remember this. That is what the idea. So, here I am showing you original data. It is a classifier. You could see there are different color of balls, right? Red, blue, green, and some other colors also present probably. So, it is classifying this way. So, therefore, you can see here it is basically classifying blue and green, right. It is not perfectly doing correctly, correct, does you understand, but so remove all the other data, but in the process it removes many of the blue data. The second learner, when it takes over from the first learner from this classifier, it correctly does it, you can clearly see it, correctly put all the blue, maybe strong blue, weak blue or blue, right, remove all the green, but it also does not take care all the blue balls, that is the error, right. In the third case, and it keeps on doing it, and in the third case you can see it is can be done in a better way or not. So, AdaBoost is a basically iterative ensemble method, remember this. It classifies, a classifier builds a strong classifier combining these poorly performing classifiers. Basic concept is to set the weights of the classifiers, remember this, and training the data sample each iteration such that it ensure accurate prediction of the unusual predictions. Okay. Obviously, when you are going from one learner to other learner, whatever mistakes or error has been committed by the first learner is taken care by the second learner. So, what we do in a step, first is basically we take an initial model, okay. Data sets consist of multiple points, a red, blue, green circle I have shown you, and we put equal weights on each data points initially. The first weak classifier will attempt to make a decision boundary is in the sense of what? Divide these different circles red, blue, greens separately, that is what it is, right. That is what is called a decision boundary between red and blue, blue and green or red and green, right. Some data points are we have shown you are wrongly classified, you can see are wrongly classified here, correct. So, in the second step we have to adjust the weights, because you put equal weights, that is not correct, that is why it could not classification properly. Second step is misclassified points from the step 1 and assign higher weights, right. You can see here they are shown by darker points, correct. These are the darker points, so you can see this, they are darker points, more weights are placed on that, correct. And the new classifier is then further trained with a refined decision boundary, focusing more on the errors done in the last step. So, there will be more points will be now corrected, and then we can step 3 you can do further adjustment, newly misclassified point from steps to can we again increase put more weights, higher weights to ensure better classification. So, basically we are changing the weights on each of these data points, red, blue and green circles, okay. And by that way we can actually classify them separately. So, classify just again using improved decision boundary, but you will find still some data will remain misclassified. So, that is why you have to keep on doing iterative process, and final classify will combine all these steps 1, 2, 3 to get strengths of all the weak classifiers, and by aggregating or by using voting we can actually predict with a much higher accuracy compared to this individual models. Okay. So, that is how the AdaBoost algorithm works. We will talk more about this in the second part of the lecture. Let us stop here and we will come back and discuss more on the second part of the lecture.